Okay, so this is how to do those last couple of problems on the homework using Cramer's rule. So I went with like just it would be lines. It's just 2D. I got X and Y. There's no Z's. So this is a 2x3 box. If someone asks you to solve that 2x3 box, I'm just going to go with RFing the whole thing and be done with it. But here's how you're supposed to use Cramer's rule. First, this 5 and 2, that's on the other side of the equal sign. That doesn't count. All right, the other stuff right here, I put that in a box. So it's a 2x2 box. You can't det something if it isn't like a perfect square. All right, this is 2x2. And when I det that, I get positive 9. Okay, so I put that in my calculator and I det it. And then I take out the 1 and the 5 out of this original box that I started with, and I replace them with the 5 and the 2 from over here. That's why they're in blue, because I've just replaced this with this. And so I have to go back into my calculator, change out that whole first column, det that, and I get a negative 1. All right, now replace the 1 and the 5. Okay, those are back how they are. And take the 5 and 2 and put that in the other column, in the Y column, and det that. Okay, so this one counts as dx because it's the one when I replaced the x column. And this one counts as dy because it happened when I replaced the y column. Okay, and now the answer to this is x is equal to dx over my original d. So dx was negative 1, and my original d was 9, negative 1/9. Well, it is. I mean, my calculator said negative 0.111, which is the same thing as negative 1/9. Okay, I managed to do that without any fractions whatsoever. The first fraction I saw was just writing down the answer. And then y would be dy over d, and that is negative 23 over 9. And that's the answer for y. Well, my calculator said the same thing. It said negative 2.555, which is negative 2 5/9, which is what that is. Okay, so I managed to do it without using any sort of fractions to calculate through the whole problem. Suddenly at the end, I got fractions as my answers. It was a good idea at the time. If I had to do this by hand, I would probably start thinking about Cramer's rule the minute it started looking like it was going to be fractions everywhere. Okay, but I'm going to ask you on the exam, on the final, it's going to say, here's a matrix, det this. So you'll have to know how to use your det button, but you're not going to have to know how to use Cramer's rule. Because if I give you this to say use Cramer's rule, I know you're just going to RF it anyway. RF is much more efficient. This, I had to do 3 different things. It's confusing. I keep replacing one column with some other column, do the whole thing again. It took forever. It would have been a lot faster just to RF that. Okay, and then I tried this one. Take these 2 columns right here and det those, and I got 0. And then replace this one with the 3 and the 15, det that, I got 0. And then put the 1 and the 5 back, replace the second column with the 3 and the 15, and I got 0. Okay, so the x is 0 over 0. Okay, now that doesn't make any sense. That's because you're not allowed to divide by 0. Same thing for y. And the reason why is because this is just the same line twice. Okay, there was no way. This is an infinitely many solutions problem. This is just the same line, the same y equals mx plus b, written out 2 different ways, but it's the exact same line. If I graphed it, I'd get the same thing twice. So that's why it's not going to give me answers. It has infinitely many answers. It doesn't know how to give me infinitely many answers. Anytime you get a 0 for that first box, you're not going to get anything like a normal answer, because you're always going to be dividing by 0 if you do. If these had come out as different numbers, if that had been a 7 and that had been a negative 2 or something, it wouldn't be infinitely many answers. 7 over 0, negative 2 over 0, that's when it would be no solution. If these don't come out as zeros, it's no solution. If these come out as zeros, then it's infinitely many solutions. Okay, and under any circumstances, you weren't going to do that anyway. Just RF that, and you would see this whole bottom line is zeros, and then you'd write infinitely many solutions on your paper.